Hi everybody, this is chapter 10 part 2, the start of it. I know 10.6 is just really long. I mean, look at how many points there are in this particular section here. There's 42. So what I'm deciding to do is skipping 10.5 because there's not much that's urgent or really important in that section, and I'm going to split this one in half. So I think I'll do through the first 22 problems, I think, is the first part, and then it kind of switches gears and gets into some geometry past that. And that's a good break, and we'll finish that one up. So we'll take 2 days to do 10.6, and then we'll do 10.7, and then we'll test on just that little unit. So it's 10.6 and 10.7, which is very small, but very important. So we'll see why we needed to take a break and get into all that factoring and all that good stuff now. All right, so we're going to still continue on in our, because chapter 10 is all about radicals, so we're continuing on in our radical chapter. And let's take a look at what we have here. We have equations. So now we're going to be solving. So let's talk about the square root of a square. Okay, what is the square root of a square? I can write it that way, or I can write it like this. Well, remember my index here is a 2, right? So if I wanted to turn this into exponential notation, remember that's 2 over 2. Remember, it's this divided by that, all right, which is just x to the first power, which is x. So anytime that this matches that, it comes out as whatever is underneath that radical sign. Okay, so even on a cube root of a cube, fourth root of a fourth, all those. Okay, so whenever they match, then you can take the whole piece of it off of there, and it's just what's underneath that radical, which is very useful. All right. Now remember, in algebra, now that we have sides, because we have equations, right, we have a left side and a right side, whatever we do to one side, we have to do the exact same thing to the other side. Okay, so we're solving for x. So we want to get rid of that square root. So here's my equation. I want to get rid of the square root over here. So the only way that I know how is by using this method up in here. I want to match this and that. So I'm just going to add a 2 in there. I'm going to square this side. But if I square this side, I have to square that side, right? So now the square root of a square is itself, and 5 squared is 25. Does that work? Square root of 25 is 5. Yeah, sure, it does. All right? So I've been really bad about checking these lately, so we'll just check these. All right. So the cube root of some number is 3. Well, we're going to do that same, we're using this logic right here. We've got the cube root of x is equal to 3. So if I would cube this side, I have to cube that side. Cube root of a cube is itself, that's 27. Is the cube root of 27 3? Well, sure it is. Let's just take a look at it real quick. Math, we're going to take the cube root, which is number 4. We're just going to remind ourselves what's going on here. Yeah, cube root of 27 is 3. Okay. Oops, can't put that in there. Check our answer, continue on. All right. Now we have more than just a solid x underneath that radical sign. We've got actually an expression, but nothing's changed. All right, so we're going to say the square root of 5y plus 1 is equal to 8. Okay, again, the first thing that I need to do, I'm solving for y here, and I need to get rid of this radical sign. So I'm going to square this side, so they match, so it matches the index, and I square this side. Okay, so the square root of a square is just whatever's underneath the radical. So this becomes just 5y plus 1. 8 squared is 64. Now I've got this nice linear equation that's super easy to solve, right? I would subtract 1 across, subtract 1 across, right? So we have 5y is equal to 63. And then I would divide through by 5. So y is equal to 63 fifths. Should we check that? Let's take the square root of 5 times 63 fifths plus 1. Now we're going to close the parentheses. See, this is your inner parentheses when we're working with that fraction, and then this one closes the radical sign. And this has to equal 8, and it does. So that is the answer right there. Okay? So we have 63 fifths. Why are we checking our results? Well, results for radical signs have one weird glitch in them. They are called extraneous roots, and we're going to start to hit those pretty soon. That means that when you get an answer, sometimes it just doesn't work. Okay, you check the results and it doesn't make a true statement even though the answer is correct. So that's one of those kind of answers that you just have to throw out. All right, and they only usually occur with radical signs. I'm not sure why they occur, but they just do. They just make non-real answers and we just throw them out. Okay? All right, let's try this one. Just to be on your toes about that, be aware of that, because those are going to come pretty soon here. So we have y plus 3 minus 5 is equal to 2. Well, I don't want to square both sides because, you know, I've got a radical minus something, right? So I'm going to try to get that over, clean it up first before I ever square. I'm going to do a little bit of work first. So on this side I have y plus 3 is equal to 7. See, now it's nice and neat. I've got just the radical on this side and everything else on that side. So now I can square and square. Okay? So now the square root of a square is itself. 7 squared is 49. So now I can solve for y very easily. These are gone, so I have y is equal to 46. Well, let's try it. 46 plus 3. What is 46 plus 3? That's 49. Square root of 49 is 7. 7 minus 5 gives 2. So that one works. Okay. All right. Here we have a mess. So we're going to clean up the mess before we start squaring. Okay? I want to isolate my radical on one side. That's my goal. So I would subtract 27 first of all. Now, hang on. Doesn't this look like this? Don't these look a lot alike? This x is just messier. It's the square root of x minus 15. But it's basically in the same form as this problem here. So what would you do first here? Well, you'd subtract your 27 across. Then you would divide by 3. Well, nothing's changed over here, except my x just happens to be this messy piece here. But whether I'm isolating just a solid x or something messy, I'm doing the same thing. So I'm going to subtract my 27 across. So this is gone. So on this side I have 3 times x minus 15 root, and this is equal to 12, right? Now I'm going to divide by 3. So what I'm trying to do is I'm trying to clean it up and isolate my radical. 12 over 3 is 4. Now I've got it back to that form that we kind of saw. You know, we're always trying to go back to this type of a form. This type of a form. You see how my radical is just the radical on that side? Every one of these just had just the radical. And then we start working into these and there's more going on, so we have to first of all isolate our radical. So that's always our first step. Now I square. So I can either, you know, go on the inside here and put the 2 wherever you want to put it. But this 2 and this 2 wipe each other out. So now we have x minus 15 is equal to 16, correct? 4 squared. And then I add my 15 across. And this is gone. So we have 31. Should we try checking it? I think we should. 3 times the square root of 31 minus 15, close your radical, plus 27. Now this should be 39, and it is. It works. Okay, so we have 31. All right, so now we're going to be looking at a little different procedure. In that, you do have your radical isolated, but we have another variable on this side, so that's a little different, isn't it? So again, I don't have to mess with it at first. I'm just going to kind of leave it alone and just square, because I've already got my radical isolated. So I have x squared equals, and the square root of a square is just itself, 3x plus 10. Okay. This is kind of like all that stuff that we were doing with factoring and the zero factor property and a times b is equal to 0 and all that good stuff. That's kind of why we took a break and looked at all that. I'm going to try to turn this into some sort of a factorable trinomial. So I'm going to subtract my 3x across first of all. So I have x squared minus 3x is equal to 10. And then I'll subtract my 10 across both sides. Remember, what I'm trying to do is I'm trying to get to a 0 on that side. All right. I look at that left side, and that's definitely a trinomial, an easy trinomial that can be factored. All right, that factors into 2 binomials. My variable is an x. My back sign is a negative, so I've got one of each. My factors of 10 are 1 times 10 and 2 times 5. I have to pick a pair that subtracts to 3. My 3 is negative, so I'm going to put my 5 in with my negative spot and my 2 in my positive spot. Remember, this is how I solve quadratics. Okay, so as soon as I see this quadratic in here, this 2, I got to go back to all my quadratic stuff. So now I have something times something is equal to 0. So I know that either x plus 2 is 0 or x minus 5 is equal to 0. 2 easy linear equations. I'm going to subtract my 2 across, or I'm going to add my 5 across. There's my 2 solutions. Okay? Now this is when we have to start really checking our work, because when we square a square root, when we were solving with radicals, we always get these extraneous roots that we have to check, so we better check it. So can I go down anymore? Nope, I'm at the bottom here. Okay, so let's put in -2. So we have -2. I'm going back to the original. I'm going to put a -2 in here, and I'm going to put a -2 in there. All right? See if it's true. We've got 3 times -2 plus 10. That should equal -2. Well, how can a radical ever be equal to a negative? It can't. So this one's not looking hopeful at all. What do we have here? We have a -6 plus 10 is 4. And I'm down at the very bottom here. The square root of 4 is 2. That is not a true statement. So this one we're going to have to toss. Let's try to see if the 5 works. Okay, put it here and here. Let's see if that one works. We have 5 is equal to 3 times 5 plus 10. We have 3 times 5 is 15 plus 10 is 25. Square root of 25 is 5. So this one checks. This one does not. Okay, see how it makes these untrue statements here? So let's just put in both, just to, I know it's wrong. We're just going to check to see what it says. So if you get a message like this, oh, that's the message. The message isn't all that helpful, is it? Check the proposed solutions. That's what we're supposed to do. So we will get rid of all that, and it's fantastic. I just want to show you what the message was in case you get that. All right. I need a new screen. Now we're going to be working in cubes. Has anything changed? Well, not really. You know, how do you get rid of a cube root? Well, you cube. How do you get rid of a fourth root? You fourth. Okay, so you're always just trying to get rid of that radical sign, no matter what it is. Shoot, I always forget to go back up to the top. All right, so now we have the cube root of x is equal to 8. Well, how do we get rid of a cube root? We cube both sides. Cube root of a cube is itself. 8 cubed is, what is 8 cubed? Probably 12. Okay. And let's check that. Let's check all these today. I'm in a checking kind of mood. All right. So here we go again. Same stuff. We have our radical isolated, right? So we're going to cube it to get rid of it, both sides. Cube root of a cube is itself, so that all comes out, which is so nice. Negative 3 cubed should be a negative 27. On your calculator, make sure that you have your negative 3 in parentheses, negative 27, and then you can proceed from there. You can add a 6 across. These are gone, so we have 3x is equal to negative 21. Dividing by 3 gives negative 7. Well, we should probably check it. We're going to go into the math key and we're going to pick a number 4 for the cube root. We want 3 times a negative 7 minus 6, and that should be negative 3, and it is, so that works. Well done. Look at all these green check marks. We're cruising. All right. I don't think anything is different there, except it's the 4th power, but we know how to get rid of a 4th, don't we? A 4th root. Take everything to the 4th power, right? So the 4th root of a 4th power is just itself. And 4 to the 4th power is 256. I'm going to add my 2 across. So y is 258. Let's check it. 4. Okay, remember when my index is anything other than a 2 and a 3, I have to hit that first. I go into math, I want the xth root, that's the number 5. I have to open up a parenthesis because that one doesn't do it for me. So I've got 258, because that's what y is, minus 2, and that should give me 4. Okay, perfect. So this is 258. Fantastic. All right. What's going on here? Well, we've got a radical on either side. So we are going to square. Okay? I'm going to square this side and square that side. It matches both of these index of 2's. So everything comes out. 10y plus 8, because the square root of a square is itself, and the square root of a square is itself. It's a little easy, isn't it? It's a little too easy. We need to get a little more challenging here. Gather my y terms. You're all going, no, that's quite all right. Y plus 8 is 9. Subtracting my 8 across. Y is 1. Well, does it work? If I put a 1 in here, I get the square root of 10 plus 8, because 10 times 1 is 10. And if I put a 1 on the other side, 9 times 1 is 9. This is the square root of 18. This is the square root of 18. That's a true statement, so that works. So we have 1. Okay? All right. Now we're going to get into some more difficult problems, just like I asked for. You're welcome. They're not difficult. They're just more steps and a little bit more work. All right, again, I have my radical isolated to one side, don't I? So I'm going to square both sides. But I'm going to square the entire side. So, if I want to do all that, I can. This 2 matches that 2. But I want to make sure that I'm not just squaring the 1. I want to square the whole thing. Okay? So the square root of a square, these two things cancel. And this is this, isn't it? Isn't that what that says? So here's a foiling problem, and I'm going to end up with a quadratic there. First term, x squared. Outside term, x. Inside, x. Last is 1. I've got x squared plus 2x's plus 1. Now again, anytime that I see this quadratic there, I'm going to want to set it to 0 and factor and solve, because that's all I know right now. I mean, there are other methods. We have, completing the square, we have the quadratic formula, we've got other methods, but we haven't learned those yet. So we're going to rely on our factoring techniques. So I want to get this all set to 0. So I want to subtract that, and I want to subtract that. These are both positives. So these are gone and these are gone, so all that's left on that side is just a nice 0. On this side, I have negative 7x's, right? I've got positive 2 and negative 9 for negative 7x's, and my 1's are canceling. This is not one of those easy trinomials because it's missing that back piece, but I do see a GCF. Let me go up here. I see a GCF of an x. If I would divide both of these by x's, I've got an x minus 7 left over. Okay? Now I've got my something times something equal to 0. So either this is 0 or this is 0. This one's solved. This one, just add the 7 across. So there's your two answers right there. There's one, and there's the other. But we do have to check. Okay, so we have to make sure that they work. So let's put in the 0. If I put a 0 in right here, I get 9 times 0, which is 0. 0 plus 1 is 1. Square root of 1 is 1. So I have 1 on this side. If I put a 0 in here, I have 1. So 1 equals 1. So this one works. So let's try 7. 9 times 7 is 63, plus 1 is 64. The square root of 64 is 8. So this side's 8. Put the 7 here, 7 plus 1 is 8. So they both work. Okay, so this time we're going to have two answers. They both are valid answers. So we've got to get them both in there. Remember, on quadratics, we're always looking for up to 2. Okay, that doesn't mean there always is 2, but there could be up to 2. All right, same thing here. Now I'm going to start not doing some of these because, yeah, I think I'll let you alone on that one. I think I'll leave you alone on that one. Now, these are all going to end up with quadratics. See how they're, you're going to be squaring that side? It's going to be the same process here. And then you're going to end up with some sort of factoring problem, whether it's a GCF or, whatever it happens to be. Okay? So I'm going to leave you alone on those. Now, this one's different. You hear my dog barking again? Ay, 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 ay. Okay, so we have the square root of x equals the square root of x minus 11 plus 1. Now I've got a radical on either side, but I already did one like that, but the radical on either side didn't have this plus 1 on it. It just had, a radical, and we squared. Well, so we're going to have to use that same logic, and it's going to be a longer problem because we're probably going to have to square root it twice. Square it twice. So let's first of all get rid of this radical. All right, so we're going to square this side. Okay, and then we have to square this side. Not just this, but the whole side. So the square root of a square, that one's easy. But this one says this, doesn't it? That's a foiling problem with some nasty stuff in there. So let's just lift this up a bit so we can get more working space here. All right. First terms. I've got the square root of, well, boy, I don't know. Okay, let me just do it over here maybe. I've got the square root of x minus 11 times the square root of x minus 11. Right? Now, my product rule for radical says I can combine those because it's got the same index under one radical. And that's the same as that because I've got 2 of the same thing. Now the square root of a square is just itself. See how that works? So that's my first term, is x minus 11. Now my outside term is 1 times square root of x minus 11, which is square root of x minus 11. My inside, same thing, plus the square root of x minus 11. See how squaring both sides wipe this one out, but not that one? So we have to do it twice. So now we have plus 1. Okay? So let's see what we can do here. We have x is equal to x minus 10, right? I've got my negative 11 and a positive 1. And then how many of these do I have? I got 2 of the same thing. I've got 2 x minus 11's square roots. So now I only have the one radical sign, so I'm going to isolate it on one side. So I'm going to want to get rid of everything else over there. Okay, so the first thing I want to do is I want to subtract an x across. Okay, so I have 0 on this side, negative 10 plus 2 roots of x minus 11. I'm going to add my 10 across. 10 is equal to 2x minus 11. Divide by 2. Come up here. I've got 5 is equal to radical x minus 11. Okay, how do I get rid of this? Square both sides. This is 25. This wipes itself out. Add my 11 across. X is equal to 36. Woo! Let's check it. All right, I'm going to take my original, that's this one, I'm going to put a 36 here and a 36 there and see if it makes a true statement. So I've got the square root of 36 is equal to the square root of 36 minus 11 plus 1. Well, this is 6, and this is the square root of 25. This is 5 plus 1 is 6. It works. 36. Woot woot, right? Good job. Okay. Well, this is almost exactly the same. Let me just show you something here. You see how I had the radical on one side, and then I had the radical plus something on this side? This time I have both radicals on the same side. That's going to make it very difficult if I FOIL from here. So what I would suggest, I'm not going to do this one because they're all done the same, just like the last one. But what I would suggest is I would, first of all, just move that square root of t over with the 6. Basically what you want to do is you want to get one radical on one side and one radical on the other side. So we're going to have square root of 2t minus 28 is equal to 6 minus square root t. Excuse me. Now you're going to want to get rid of this radical by squaring. So you square this side, square that side. This comes off. This is foiling, right? I'm going to leave you alone from here. I think you've got it. Foil. Then we're at this point right up in here. We're foiling, we're solving, we're moving things around, we're squaring again, and finding our answer and checking it. Okay? Does that sound fair? I sure hope so. Same thing here. Maybe we should do, I don't know, we should do another one of these? You're all going, I wish I could ask and then you guys could just actually tell me what you think. Yes, we need to see another one. But I don't know. Maybe no, we've seen quite enough. Maybe we should just do one more of these, huh? Let's look to see what's in here. Yeah, this is the last one, and then we kind of switch gears again, so. Do you know how to fast forward the video? You can always fast forward the video and you can kind of see my pen, and then when I switch to problem 17 you can start it up again if you don't want to see this. But I think what I'm going to want to do again is get my radicals. I forgot to go up to the top of the page again. Oh well. I'm going to want to get my radicals on one on either side, so this is gone. So now I have the square root of x plus 2 is equal to 1 plus the square root of x plus 3. Square, square. Square root of a square is itself. And I'm going to rewrite this up here so I can save myself some room. That's what this means. Why did that become a plus? I don't know. It shouldn't be a plus. I don't know what happened there. Okay, let me get, oh here, I'll show you my little eraser. I like my little eraser. Okay, so this is gone. This is gone. This is gone. I like that. I think that's pretty cool. All right, so this is supposed to be a minus. I don't know why I changed that to a plus. This becomes a positive, but this stays a negative. All right, so let's FOIL again. 1 times 1. And I've got one of these and another one of these, so I have two of those. And then I have this. The square root of x minus 3 times the square root of x minus 3. Remember what that was? we can say that's the square root of x minus 3 squared. I've got two of them, which is x minus 3. Okay? We have a positive and a positive, so these are all positive things. Okay? Well, let's combine our numbers for negative 2 plus 2 roots of x minus 3 plus x. Subtract my x across, so my x's are gone, which is decent. Add my 2 across, so I've got 4 on this side. 2 roots of x minus 3, and then I'll divide by 2. So I have 2 is equal to the square root of x minus 3. Well, now I got to get rid of this radical, so I'm going to square both sides. So I've got 2 squared is equal to the square root of x minus 3 squared, right? I'm just going to add my 2. This is 4. This is wiping itself off of there. And now I can solve. 7. All right, let's check her. So I'm going to put the 7 in wherever I see the original problem. So I'm going to put a 7 in here, and I'm going to put a 7 in there. Okay, so I'm going to have 7 plus 2 minus 7 minus 3 is equal to 1. 7 plus 2 is 9. 7 minus 3 is 4. Square root of 9 is 3. Square root of 2, or square root of 4 is 2. 3 minus 2 is 1. Check. So my answer is 7. Excellent. So on these, when you have the double square root, you're going to have to square it twice. Okay? You're going to want to set your radicals on either side so that they're opposing each other. And you're going to want to get rid of one and then the other. And just be careful on your foiling. This is a long process to foil something like this, but it's no different than a regular binomial times a binomial. It's just messier. All right? Okay, so now we're going to kind of switch gears here. Go back up to the top. See how long this is? I'm already almost 38 minutes into this, and I've only covered 16 problems. There's 42 in here total, so we'll go up to number 22, and then we're going to be done with this half of section 10.6. So, and I didn't feel like I could take anything out. It was all important in there. So, all right, so now I have squares. Okay, now let's just go back in time just a little bit. If I said to you, what is the square root of 25? And what I'm looking for is what number multiplied by itself 2 times will give me 25? And you would say 5, right? Because whenever we just evaluate a root, we just give the positive value. But really, there's that negative in there too, right? We just said for a while we're going to disregard that because this is just an evaluation of a number. Okay, even the calculator ignores that negative. Okay, 25, it'll just give us the positive or the principal root. But really, negative 5 times negative 5 is also 25. So there is that negative in there. And whenever we solve, and not just evaluate, but now we're solving, we have to take into consideration the negative. So, very important. So, if I would get rid of a square, can I square root? Well, sure. Both sides, right? The square root of a square is itself. So what I'm trying to do is I'm trying to wipe this square out. And I'm going to show you another way to do it too. So the square root of a square is itself. And this has to be the positive and the negative values because I'm solving right from this. So x is equal to positive and negative. The square root of 169, I believe, is 13. Better check that. 169. Yep. So positive and negative 13. Okay, so those are your two answers. What's another way of doing that? Well, I can just use my factoring techniques. And remember, whenever I see a quadratic, I want to set it equal to 0 and factor and solve. So I can subtract 169 across. So I have x squared minus 169 is equal to 0. This is a difference of squares, so I can factor that. 1 plus, 1 minus. Square root of the front one goes in the front. Square root of the back one goes in the back. So either this is 0 or this is 0. So either this is negative 13 or this is 13. All right? Your choice. You can either use the square root principle where you're just square rooting a square to get rid of it, or you can factor. But in any case, we have 13 and negative 13. Now, we don't have a plus minus key on MyMathLab yet. I've asked for one for a very long time, but we haven't gotten one yet, so you're going to have to put those in separately. Okay? Of all the things on this tool palette, you'd think that they could come up with a plus minus key, but apparently it's a lot harder than we think. All right, so let's try another one. We have this. Now, this one I think is going to be a lot easier just to square root than to factor. Sometimes one method's a lot easier than another method. So I'm going to square root to get rid of this square on this side as well. So the square root of a square is just itself. And I've got positive and negative, right? Because I'm not evaluating, I'm solving. Square root of 64 is 8. So it could either be positive 8 or it could be negative 8. So now I'm going to keep, for right now I'm going to just pretend like that's not there. I'm just going to keep dragging it. I'm just going to start solving for k. Okay, so what I want to do is I want to add my 2 across. I don't want to combine these. These are gone. So I've got 5k is equal to 2 plus or minus 8. Then I want to divide through by 5. So k is equal to 2 plus or minus 8 over 5. Now I can split this into two different solutions. I can say it's either 2 plus 8 over 5 or it's 2 minus 8 over 5. So I'm going to take both positive and negative values and I'm going to actually see what these come out to be. 2 plus 8 is 10. 10 fifths is 2. 2 minus 8 is minus 6. So there's my two solutions right there and right there. We better check these. All right. So let's try the 2. 5 times 2 minus 2 squared should give me 64. Well, let's see what we got going on here. We've got 10, right? 5 times 2 is 10. 10 minus 2 is 8. That works. 8 squared is 64. So that one does work. 2 works. Let's try the negative 6 fifths. Okay, so I've got 5 times negative 6 fifths minus 2 squared is 64. Well, 5 times a negative 6 fifths, look what we have here. We have 5 over 1 times negative 6 over 5. These are canceling, so I just end up with a negative 6. Negative 6 minus 2 squared equals 64. Minus 6 minus 2 is minus 8. And minus 8 squared is 64. That one works as well. So they both work. These are both true statements. So you have 2 and negative 6 fifths for your answer. And again, we're going to just, plunk those in here. Negative 6/5. Good job. We're getting close to being done here. I'll leave you alone on that one. How do you get rid of a cube? Cube root. Cube root both sides. Bing, bada, boom. Should be -3 for your answer, by the way. Oh, okay. So let's do some bigger equations with cubes. Remind myself to go all the way up to the top this time. There we go. So we have x plus 4 cubed equals 27. I'm going to cube root and cube root. All right. So now I have x plus 4, because the cube root of a cube is itself, is equal to, and the cube root of 27 is 3. Right? Let's check that. Cube root is number 4. 27 is 3. Now why doesn't this one give me the positive negative? Well, what is -3 times -3 times -3 27? No, that's -27. So this is an odd even kind of a thing. Okay, so this one you're only going to get the one solution in there because you've only got 3. All right, because -3 cubed is -27. That's not what this says. So again, you've got to make sure that you know, whenever you have an even, that's when you get that plus minus, because on even ones are the same as, right? But not these. All right. So what do we have here? We have subtracting our 4 across. So we have a ridiculously easy answer, -1. Put the -1 in here. -1 plus 4 is 3. 3 cubed is 27. So that one works. We should only have the one answer. Okay. Let's do, I think I'm going to do that one and then that one and then, yep. Okay, so we've got 2 left. All right, so here we have the 4th root. Do we have an odd or an even? Well, that's an even, if I've ever seen an even number. I'm not talking about this number, I'm talking about the power. I'm going to take the 4th root. The 4th root of a 4th is itself, and here I've got a positive and a negative because I've got an even. So I want the 4th root, I want a number 5 of 2401, and we've got 7. Because let's check it. Let's do positive 7 raised to the 4th power gives me 2401, but also a -7 raised to the 4th power gives me 2401. So it has to do with this being odd or even, whether you get the double answer or you get the single answer. Okay, so this is 7 and -7, is that right? That's right. And let's do, well, this one, you know, you're going to want to divide through by 4 first. Okay, well, it's the last one. Let's just do it simple. Don't be lazy. All right, so we're going to divide through, because I want to isolate that 4th, right? Just like I wanted to isolate my radical. I want to isolate my power. So I have x plus 3 to the 4th power is equal to 64 divided by 4 is what? Oh, now I'm being really bad. Yikes. 16. Of course it's 16. Now I'm going to take the 4th root of a 4th. 4th root of a 4th. The 4th root of a 4th is itself. So I've got x plus 3. We've got the positive and negative because that was a even. The 4th root of 16 is 2. If you've forgotten that, then you go into your calculator and you let the calculator tell you that, but it's 2. So we have plus and minus 2. Now I'm going to subtract my 3 across, and I've got plus or minus 2 minus 3. So then I split. I've got -2 minus 3, and I've got 2 minus 3. This is a -5, and this is a -1. So let's check these. Let's put the -5 in here first. That's supposed to be a true statement. -5 plus 3 is -2. -2 to the 4th power is 16. And 4 times 16 is definitely 64. We just checked it on the calculator. Okay, so the -5 works. Let's try the -1. 4 times -1 plus 3 to the 4th is equal to 64. Well, we have what in here? We have a 2. 2 to the 4th is 16. Check. So those are our two answers. They both work. -5 and -1. No spaces in between those, okay? All right, so I will stop here. So I suggest you do the same. You know, pick up on number 23 when you come back for the next lecture. And it's really kind of changing a little bit. You know, we're starting to get into some geometry with some triangles and things like that. So I will see you for that particular section in a little while. Good luck.